Okay, let's start. So we're looking for the second derivative of the function. So this will be a two-step problem. We're going to first find the derivative of this function, and then we'll find the derivative of the derivative. All right, so right off the bat, you want to rewrite the function as 3x minus 7 to the 1/2 power, and that way we can see we can much more easily do the chain rule. Okay, so for the chain rule, you bring down your exponent, leave the inside alone. You subtract 1 from the exponent, and now you do times derivative of the inside. Derivative of 3x minus 7 is simply 3. So then we have the equation okay, so that's your first derivative. Now we're going to take the second derivative, which is simply doing it again. Okay, bring down the exponent again, multiply negative 1/2 times positive 3/2. You get negative 3/4. Inside stays the same. Minus another 1 from the exponent there. Now we multiply by the inside. Derivative of the inside. And simplifying that, we get negative 9 over 4. And I'm going to put the exponent out of negative form by putting it on the denominator. And that's our solution. Okay, so that's for number 11. Number 12 is simply another double derivative. So we're just going to work this problem again. So step 1 is you take the derivative. So we're going to use the quotient rule here, right? Which is low d high, low d high minus high d low, all over low squared. Okay, I'm going to simplify that. So that's x plus 1. And this is minus just an x. And we'll see that this simplifies further to 1 over x plus 1 squared. Because the x's here cancel out positive and negative. And now we take the second derivative. And we can see that we could just rewrite this function here as x plus 1 to the negative second power, because there's nothing in the numerator that has an x value, it's just a 1. And so here we'll do the chain rule. So bring down the negative 2, leave the inside the same. And now we multiply by the inside, which derivative of x plus 1 is just 1. And so we have negative 2 over x plus 1 cubed. And that is the answer to number 12. Moving on to number 13. Find the requested value of the second derivative of the function. So we got to get the second derivative, and then we have to plug in at the x value of 2. And if you notice, this is the same function as from number 12. So we're just going to take that function It's the same function as the one from number 12 that we started with, so the double derivative we've already found. We're just going to plug it in. Okay, so we have -2 over 2 plus 1 cubed, which would be -2 over 3 cubed, which is simply -2 over 27. Nice. Okay, so for number 14, we're back to finding the double derivative of the function again. So, as always, we start with finding the first derivative. Okay, so the derivative of an exponent, e, is, you rewrite it again, so you just rewrite it, times the derivative of the exponent part itself. So the derivative of -x squared is -2x. And we can simplify this to become -8x e to the -x squared. And now we're going to take the second derivative. So bring down the -8. And now we have a power rule, or not a power rule, product rule. So we're going to do first times derivative of the second. X squared times -2x, just like we had above, plus the second times derivative of the first. So first, second. Okay, so now we're going to simplify this to get our final answer. That is -8 times -2 is +16. X times x is x squared. E to the -x squared minus 8 e to the -x squared. Okay, and that's our answer for number 14. And now we're going to just find that value of when x equals 5 for the second derivative of the function we just solved. So here we just simply plug it in. Equals 16 times 5 squared e to the -5 squared. Remember, the negative sign is on the outside of the square, so we leave it there, minus 8 e to the -5 squared. 16 times 25, because 5 squared here is 25, gives you 400 e to the -25 minus 8 e to the -25. And so this simplifies to 392 e to the -25s. And that's our answer. Awesome. Okay, so we're going to find the indicated derivative of the function. Here we have f 4x. So that's f, the fourth derivative of f of x. So we're just going to take the derivative 4 times. So let's start working through it. F prime of x, this is just power rule. So that's 12x fifth minus 28x cubed plus 14x. F double prime is 60x to the fourth minus 84. So 3 times 28 is 84, x squared plus 14. F triple prime is 240x cubed minus 168x, and then derivative of 14 is 0. And quadruple prime, or the fourth derivative of f of x, is 720x squared minus 168. And the last line is your answer. Okay, moving on. Number 17. Find the open intervals where the domain of the function is concave upward or concave downward, and then find any inflection points. So right off the bat, we notice that we can see this graph here has 2 curves, 1 and 2. And we see that this side is concave up, while this side is concave down. And the switch happens right here at the point 0, -1. And simply checking concave up and concave down is, does the curve open downwards or does the curve open upwards? And so we're going to write this as intervals. So concave up at the interval 0 to infinity. And that's our green section there. And concave down is simply the other half of our curve here, -infinity to 0. Right? And we needed to find any inflection points. We have an inflection point right there. It's where it switches from concave up to concave down at 0, -1. And those are our answers. Awesome. Going to number 18. The function gives the distance traveled in t seconds by an object. Find the velocity and acceleration of the time given. So velocity is the first derivative and acceleration is the second derivative. So we're just going to find v of t, which is also just f or s prime here. So this looks like it's just the power rule. So 9t cubed turns into 27t squared plus 3t squared turns into 6t plus 5. And then that's our velocity. So let's plug in at t equals 2 equals 27 2 squared plus 6 times 2 plus 5 equals 27 times 4 plus 12 plus 5 equals 125 feet per second. And we know that derivatives are always rates of change, so we need to remember that it's feet per second. Okay, but we're not done because we need to also find acceleration. So acceleration is just the derivative of velocity. Right? Or the second derivative of position. Okay, so 27 times 2 is 54t plus 6 now. So acceleration at time equals 2 is 54 times 2 plus 6, which is simply 114 feet per second squared, because that's the second derivative. And that's our answer for number 18. Velocity and acceleration. Okay, so moving on to number 19, find the largest open intervals where the function is concave upward and concave downward. Find any inflection points. So this is similar to what we did above with the graph, except we're going to do it algebraically now, or using calculus. So to find concave up or down, finding concavity, we look for the second derivative and then the inflection points, which is where the second derivative equals to 0. So what does that mean? I'm going to show. So first we just take the derivative. And take the second derivative. 24x minus 90. Okay, and now we set this equation equal to 0. We add 90 to both sides, which is going to give us x equals 90 over 24, which we can simplify down to 15 over 4. Okay, so now we found our critical point. We have a inflection point at x equals 15 over 4. We put this on our number line. 15 over 4, and now we just simply plug in two values. So we know that easy values would be whole numbers, and 0 is a very easy number to calculate with. So I'm going to do 0 on the left-hand side, 4 on the right-hand side. Okay, so at f double prime of 0, we have (24 times 0 minus 90, which means this is a big negative number. And f double prime of f equals 4. We have 24 times 4 minus 90, which is going to give us positive 6. So this is a positive value. And so from there, we know that from 15 over 4 out to infinity, we have concave up because it was a positive number. And from 15 over 4 down to negative infinity, we have concave down. Okay. So that gives us our concave up, concave down. The last step we want is to find out the pair that goes with the x value of 15 over 4. So we go back to our original function and plug that in. And I'm just going to do this on my calculator so that I don't have to do it out. Okay. You get the crazy fraction of 1125 over 8. So then to complete our problem, we have concave up at the interval of 15 over 4 to infinity. Concave down from negative infinity up to 15 over 4. And then our inflection point is x value 15 over 4 and y value 1125 over 8. And that is our answer there, solving it using calculus methods instead of graphically. So the note here that we have to remember is that when we're finding the inflection point, we're using our x value into the original equation. I didn't do it using the derivative because we already know that that would equal 0. We're doing that from the original equation to give us our inflection point, and the concave up and down are the two values that have to do with our inflection point going off on either side to infinity. Okay, so for the last problem here, we're going to do the same method again of getting the second derivative. Okay, I'm just gonna work through this quickly. Okay, so now we set the equation equal to 0. And the first thing I notice that we can do is we can pull out a 24x, leaving an x plus 2 left behind, because 48x times 2, or 24x times 2 equals 48x, and then 24x times x equals 4x squared. And that's how I factored out that part. So we see that if we plugged in 0 for this value, we'd have 24 times 0 times whatever's on the inside, which means that x is a solution when it equals 0. And then we also know that if we plug in -2 here to balance out the +2, we find that that would also give us a similar result where you have 0 times x times 24, giving us 0. Okay, so these are our two inflection points. We're going to make that number line again. -2, 0. So now we're going to figure out what points we want to use. So whole numbers, the easiest whole numbers, we got 1 from 0 to infinity. From 0 to -2, we have -1. And from -2 out to infinity, we could use -3. And those are some easy numbers for us to use for our ranges. So f double prime of -3 will give us 24 -3 squared plus 48 times -3. And this will give us a positive number, I'm pretty sure. It'll give us a positive number. Just checked it on the calculator to make sure. F double prime of -1. this will give us 24 times 1 minus 48. That's a negative number. It's a negative 24. And last but not least, f double prime of positive 1. And we notice right off the bat, this is going to be positive because every value in our equation, when we plug it in, is positive. So now we know that from negative infinity up to -2, we have concave up. From -2 to 0, we have concave down. And from 0 out to infinity, we have concave up again. Okay, so to write out these intervals, we would do concave up from negative infinity to -2 union with 0 infinity. Concave down would be the interval in between, so -2 to 0. And the last part is to find the inflection point. And for that, we have to go back and plug in our x values we found in the double derivative, plugging it in for the original equation. Okay, so f of 0 is 2, 0 to the 4th plus 8, 0 to the 3rd, which we see that equals 0. F of -2, 2 to the 4th plus 8, -2 to the 3rd, which so that's 2 times 16 equals 32. And then 32 minus 64, it looks like, because that's -8 and +8. So 32 minus 64 is -32, which would give us our inflection points at 0, 0, which we found there, and -2, -32. There you have it, folks. Those are numbers 11 through 20. I hope that this video helps you out on the upcoming exam.